Welcome back. In this video, we're diving into hypothesis testing, the process of analyzing your A/B test result and making data-driven decisions. Let's get started. Every A/B test starts with the hypothesis. The null hypothesis assumes there is no difference between the control and variant. The alternative hypothesis assumes there is a difference. Your goal is to determine whether to reject the null hypothesis based on your data. Let's make it more straightforward for non-tech people. The hypothesis that I assume control group are exactly the same as a test group. So it means the data I collected from the test group will have a great chance, usually 95%, to fall into a distribution like control group. However, I allowed a 20% error that the data from the test group can be in extreme case from the test distribution, which is controlled by the sample size. Now, the t-test assumes the control group follows a norm distribution, a perfect bell shape with sample mean as a mean and sample variance as a variance. If the sample size meets the requirements, which means meets both type 1 and type 2 error requirements, we can test the p-value of how possible that I can randomly sample such test group data or even much skewed data from this norm distribution. If the probability is high, which means they can be from the same distribution. On the contrary, if the probability is extremely low, like less than 0.05, then it's impossible that this data is from the same distribution. To test your hypothesis, you will use statistical tests. Here are the most common ones. If your sample size is small, typically under 30, use a t-test. For large sample, use a z-test. Both tests compare the mean of your control and variant group to determine if the difference is statistical difference. If you are testing more than 2 variants, use a pairwise test to compare each pair. But remember, the more comparison you make, the higher the chance of false positive. In multivariate test, you will need to adjust your significance level using methods like Banforial correction. Before running your t-test or z-test, check for homoscedasticity, equal variance between groups. Why is this important? If the variants are unequal, your test result might be unreliable. For example, unequal variance can lead to incorrect p-value, increase the risk of false positive or negatives. If the variants are unequal, use a modified test like Welch's t-test. Depending on your scenario, you might need other tests like ANOVA. Use this when comparing more than 2 groups. Chi-square test, ideal for categorical data like comparing conversion rates. Winning U-test, a non-parametric test for non-normally distributed data. Choosing the right test ensure your results are accurate and meaningful. Once you're running your test, you will get p-value. If it's below your significance level, usually 0.05, you can reject the null hypothesis. But don't stop there. Looking at the confidence interval too to understand the range of possible effective size. Sometimes you will see conflicting results like one metric improve while other worsen. In that scenario, prioritize your primary metrics. Focus on the metric that align with your business goal. Dig deeper. Use segments or cohort analysis to understand why metrics are conflicting. Consider trade-offs. Decide if the improvements in one metric outweighs the decline in others. Finally, it's time to make a decision. If your results are statistically significant and practically meaningful, implement the winning variance. If not, consider running the test longer or revisiting your design. And that's it. By combining carefully experiment design with rigorous hypothesis testing, you can make confident, data-driven decisions. Thanks for watching, and don't forget to like, subscribe, and share your A/B test experience in the comments. See you next time.